Hello and welcome to Richardson RFPD Tech Chat. My name is Michele Sclocchi and I'm the application engineer with Richardson RFPD, part of the energy and power technical team. And they have the pleasure to have here with me Nicola Femia. Nicola Femia is a professor of the University of Salerno. He's overseeing the Department of Power Electronics. Welcome, Nicola.
Hello, Michele. Thank you for inviting me. I'm happy to be here today with you.
With Nicola, we are organizing a technical course, a full-day technical course on GaN devices. This course will be held in Bologna on the 30th of May. I will discuss some of the characteristic of GaN power devices. But let me go straight to the questions. Nicola, design engineers usually are struggling to calculate the switching losses for a high switching frequency design, especially when using power GaN devices. Do you have any straightforward method of recommendation to assist with this calculation?
Yes, of course. I'm going to share just a very short presentation to support our discussion. The problem is that when you want to get the on and off energy, you must be aware of what is the scheme, what is the electrical configuration you are considering, because much depends on what is the device you couple with the device under test to get this information. And the problem is that if you want to understand what happens, you have to look at the waveforms of current and voltage during the transitions in order to get the right and correct shape of the instant power that is dissipated by the device. What happens is that if you want to make it by measurements, sometimes you are not able to reconstruct the correct shape of the peak power during the transition. Then you need some model like the LT-SPICE models. And in this regard, if you want to get some reliable result, you may go through LT-SPICE simulations using the very accurate models, but the problem is that if you want to simulate either a double pass circuit or an alpha bridge, you get a lot of time. And this makes it difficult to perform the parametric investigations that designers need to do in order to set up a good converter. Conversely, if you extract the information from LT-SPICE simulation models and you construct some specific MATLAB very, very simple codes, you may get the same good accuracy as LT-SPICE and make very fast calculations, making very easy the parametric optimization. For example, such kind of model that we will discuss during the incoming course that we are going to deliver on end of May, you can get some investigation about the impact of the peak ripple inductor on energy dissipated during commutation switching times and peak current of the channel during transition. And you can do the same through, for example, the gate driver voltage or the on resistance and off resistance. These can help demystifying some common belief about GaN devices that can lead to bad design. And we will try to educate people on making the good reasoning and good calculation to avoid this.
Thank you, Nicola. Very, very interesting. The next step, of course, for a designer is to go on the lab and try to verify the performance of the GaN device in their specific application. Do you have any recommendation, any tips how to make this kind of measurement in the accurate manner?
Of course, this is one of the topics that we will discuss in this incoming course. Just to say, the problem with GaN is that they have very small capacitance. As a consequence, they switch very fast. As a consequence, you have a first problem, that is which is the right measurements we have to do in terms of what to measure. which current, which voltage, between which parts of the circuit nodes, and which probe to use, which bandwidth, differential probe or passive probes, large bandwidth, short bandwidth, and how to make some combination of measurements done in order to get the waveforms of interest. By the point of view of the switching losses measurements, you must be able to get a very clean set of waveforms, like, so, for example, the one you see here. Clean waveforms doesn't mean that you have no ringing, because you have parasitic parameters of the PCB, and you may have an undesired impact of the parasitic of the probes themselves. So it's important to select the right probes, right bandwidth, the right oscilloscope, and to set appropriate channel parameters like the bandwidth, like the resolution, the vertical scale. And finally, you must be aware of the impact of some, let's say, insidious problems like the disque of probes. That is very important in order to reconstruct the peak power waveform that can be, for example, integrated by an oscilloscope to get the energy graph, and then measuring the right value of the power loss. In this last slide, I just show you what is the reality of a commutation in a power GaN. You have very high ringing, and especially in certain commutation, and you must be aware of reconstructing the right peak. So a good measurement setup based on a complete awareness of the problem itself of GaN commutation that we will discuss in this seminar, as by point of view of just understanding the behavior as on understanding how to predict the waveforms, is the fundamental step to make good measurement. Then you have to select the right instrumentation, the right probe, and make the right setup of all these to make the correct measurement. But this is possible, and we will show how.
Thank you, Nicola. Very interesting information. And by the way, we will be able to hear more about the same topic during your technical courses that you will hold at on May the 30th. You can follow the link below for the registration. Nicola, thank you very much for joining us today. It's always a pleasure talking with you.
My pleasure, Michele. Thank you for the invitation. Thank you.
Thank you.